Welcome back. This is graphical characteristics. It's lesson 3 in unit 1. So we're going to start off with major things you already should know how to do. Gathering the domain and the range. Well, the domain is just a set of x values that produce y values or outputs. And this domain extends from -4 all the way over to infinity. It doesn't end. It keeps going from -4, if you follow it, all the way over to infinity. Okay? Now the range is a set of all possible y values. Extends from -infinity from the bottom up to 5 to the top. Okay? From the bottom to the top. The x-intercepts, you got to remember from Algebra 1, x-intercepts, these are the points. These are the values. These are the points where an object crosses the x-axis. So the points where an object crosses the x-axis. Closely linked to zeros. If you don't recall what zeros are, zeros are just the x values. Zeros are just the x values. Okay? So x-intercepts, though, are always in the form of x, comma, 0. So circling my first x-intercept, I see I have -4, 0, -4, comma, 0. My second x-intercept is at -1, comma, 0. My third x-intercept is at 5, comma, 0, where it crosses the x-axis. My zeros, on the other hand, write it down, are x equals -4, -1, and 5. Now, my y-intercept is right here at 0, comma, 3. It's where the object crosses the point where the object crosses the y-axis. Always in the form 0, comma, y. And my y-intercept is 0, comma, 3. Now, critical points on a graph include minimums, and maximums. And not necessarily a critical point, so we won't touch that yet. So just squiggle through that little line, those blanks there. But maximums, this is the point with the highest y value in the section of the graph on the top of a curve or peak. For instance, maximum would be at the top of a curve or a peak or an object with a peak. So the maximum for this curve is located at my bad. The maximum for this curve is located at right here. So right there, and that's positive 1.5, comma, 5. Positive 1.5, comma, 5. Okay? The minimum is the point with the lowest y value that it's on the section of the graph on the bottom of a curve or a peak. Okay, so it looks like this or it looks like a valley. So this minimum is right here at that valley, and it's at negative 2.5. The y value, if I count down, is negative 4. So negative 2.5, comma 4. Okay, moving on. What about intervals of increase, decrease, or intervals where it's constant? Well, when you always look from left to right, we're talking about x values. Like basically here, we're identifying these intervals. We're talking about what's happening from -5 or -4 over to, you know, 0. What's happening on the interval? What's happening from, I don't know, 8 over to some other number? On the x-axis, what's happening to the graph? Well, I can tell you the easiest way I have for doing this is I make arrows going from left to right on this graph. So make sure you have your pen. We're going to make arrows, and we're going to go from left to right, make arrows all the way. Okay, so, all right, we're ready. So we always look from left to right, increasing when going up. Okay, and like I said, I usually just try to make arrows on this map. So just making my arrows, and if you look, it's not increasing, but here from -5 all the way over, if I keep going on the interval on the x-axis, it increases from -5 to -3. So from -5 to -3 on this interval, it's increasing. Interval decrease is where the arrow is pointing down. So my first interval is from -6 over to -5. All right? So from 6 to 5. Second interval, well, it keeps going straight along this interval here. So from -3 over to, looks like 4, straight. But then it starts angling down at 4, all the way to infinity. Okay? So now I know that when it's decreasing, it's going down, it's pointing downwards. It's constant when the y values or the inputs remain the same. The range is the same. Okay? So that's just a little practice for words. So essentially, from -6 to -5, there's an interval of decrease. Put a union there. From 4 to infinity, there's another interval of decrease. Now, from -3 to 4, the y values are constant. They're the same. Now, when we're talking about in behavior, you're going to need to look at what happens to the y values on either side of the graph. So as x goes towards positive infinity, it's going right. It's going towards the right. The graph, the object, we're going to trace it towards the right. And we want to see what the end of this graph looks like. Is it going towards infinity? Did it stop at a number? As we go to the left, we want to see what this graph looks like. To the left, that says x goes towards negative infinity. Did it stop at it? Did it begin at a number? Did it continue to negative infinity? So let's look towards the right. Let's see if we see an arrow or a point at the end. Well, on the right, I see an arrow. That means the y values have gone towards negative infinity. On the left, my y value has gone towards 1. Okay? So that means I'm going to write as x approaches towards the right. As x approaches infinity, y, f of x, approaches negative infinity. Now, as x approaches towards negative infinity, or the left, y approaches not positive infinity. You got to be careful. I'm tricky that way. It approaches 1, guys. 1. Okay? For the asymptotes, and just basically in analytic geometry, that's a big word. Analytic geometry. That's basically going to be a part of every math class you take going forward. So asymptotes are. And asymptotes, it's the way it's described here, it's this line. It's imaginary. So curves, sometimes when they're formed, have a tendency to flatten out. They have a tendency to flatten out. I can show you these areas of flattening. So horizontally, I have this area, it's flattening, and it's going towards this number, but it never quite reaches there. That's what the horizontal asymptote is. If you look on the other side, this object is going towards this number. It's flattening, but it's never quite getting there. It's approaching a number it can't quite get to. It wants to get close, but it can't get too close. Vertically, here, this asymptote is kind of like, it's just marking off. It's marking off this territory. It's kind of like if you get into a fight with somebody, and you're like, dude, if you take one more step, the vertical asymptote is telling this curve, if it gets any closer, it's going to be a problem. But that's my analogy. Don't go telling that analogy. That's my analogy. All right? So let's look at these last two problems. We're going to look at the vertical asymptotes. And the way we identify the vertical asymptote, it's just x equals a number. It's just x equals a number. Don't go crazy, guys. X equals a number. So wherever that imaginary line is going through, that's the number it equals. So right here on the left, I see my imaginary line. If you don't see that line, well, I don't know what to tell you. If I count over, -1, -2, -3, I have x equals -3. Count to the right, I have x equals 3. Now, if I look at my horizontal asymptote, I have y equals 2. Y equals 2. Over here, my vertical asymptote is x equals, looks like 1. My horizontal is y equals 1. Okay? Now, if I wanted to do the domain and range based off of this, my domain, if I look at my x values, where I have asymptotes, I kind of know where my holes are. So from negative infinity to -3, and then -3 to 3, and 3 to positive infinity. That's what the domain looks like. So I could literally write negative infinity to -3 with parentheses, put a U, union for union, and then -3, comma 3, and put another U for the union, and then 3 to infinity. If you're confused, please go look at a video about domains and ranges. But what the vertical asymptote and the horizontal asymptote allow us to do is to kind of map out parts of the intervals very easily or more easily than we ever thought they could, or than you imagined they could from the last time we looked at hyperbolas. Okay? Now the range using your horizontal asymptote, your horizontal asymptote, that range is going to start negative infinity, go up to 2, and then keep going to infinity. So from negative infinity, go up to 2, put a union, start at 2 again, keep going to infinity. So I'm going to let you think about the last one for a second. Think about that there's one little dot here, and it's coming from negative infinity, the domain, to 1, union, 1, infinity. The range, negative infinity, 1, u, 1, infinity, close parentheses. Okay? We're going to do number 1. I'm going to allow you to do number 2. Please keep in mind that these are all x-intercepts for number 2. And if you just put a little note right here, x-intercepts, and make sure you put why Miss Smith. Why? So I know that you're saying to me, why? Why did you choose this particular graph, Miss Smith, when you know that there's an infinite amount of x-intercepts in number 2? I don't know. But we're going to do number 1. So starting from the left, remember, if it's heading in any direction in the left, we're coming from negative infinity. And there's an arrow, so it's definitely negative infinity. We stop. If we keep going to the right, we stop at negative 1. But we keep continuing at negative 1, and we go on and on towards infinity. That means there's no breaks in this domain. So negative infinity to positive infinity. There's technically no breaks here. Covers every point ever. Now my range, on the other hand, we're coming from negative 3, and we're going all the way up to infinity. So from negative 3 all the way up to infinity. My x-intercepts, I only have 1 for this particular graph. It looks like about 1.8, comma, 0. My y-intercept, there's 1 here at 0, negative 3. This also happens to be the minimum of my graph. There is no maximum, so I'm going to just go ahead and fill in the minimum. There is no maximum. Remember, the zeros are just the x values in the x-intercepts, so x equals 1.8. The interval of decrease is where this object is decreasing. So I'm going to erase some of the things that I put up here already because it looks really messy on there. And I'm just going to go back and make some arrows here so it's a little bit clearer for you guys. All right. So obviously this is a interval of consistency, being constant, right? So negative infinity to negative 1, it's constant. Then from negative 1 over to 0, it's decreasing, right? So negative 1 over to 0, it's decreasing. From 0 to infinity, it's increasing. And it's constant from negative infinity to negative 1. There's no asymptotes. The end behavior on the left is that it's going to negative infinity. It's going to 1 on the y values. So as x goes towards negative infinity, the y values, or f of x, goes to, it actually goes to 1. As x goes towards the right, or to positive infinity, f of x goes to positive infinity. Okay? So you do the last one on your own. Do the classwork. Do homework 3. You guys make me so proud. You probably didn't listen to all this video, but that's okay, because I'm going to see you on Monday, and I'm going to make you do all this work. Have a good weekend. Bye.